Welcome dear students in the class. Today we will discuss the topic asymptotes of the book Differential Calculus. So telling about the asymptotes, first I will tell you that what is asymptotes. Generally a straight line cuts a nth degree curve in endpoints. When in general second degree curve a straight line cuts at 2 points, when these 2 points tends to a single point, we say point of contact, this line of intersection becomes tangent. So asymptotes are a special type of tangents, or tangent takes the position of asymptotes in infinitely extending curves when we move the point of contacts away and away from the origin. That is, it means when point of contact tends to infinity, the tangent takes a fixed form of a straight line, which is called asymptotes. Generally, we are telling you some few curves. See here, this curve is an hyperbola, and you are seeing that this curve is infinitely extending. Second curve, we are simple curve, it is a parabola, y square is equal to 4ax. It is also you seeing that in some direction two branches are extending infinitely extending. And in third case, it is a simple closed curve, circle x square plus y square plus is equal to a square. So note that asymptotes always exist in the curves which are infinitely extending. So in circle there is no asymptote. But here you see in the parabola y square is equal to 4ax, it is although infinitely extending, but it has no asymptote. And in this case, this curve is hyperbola xy is equal to c square. See its tracing, and it is infinitely extending curve and is possess asymptotes. So asymptote exists only in infinitely extending curves. So you understand what is asymptotes. Now we will tell you a general method of finding asymptotes. If you have given a nth degree curve and you have to find out its asymptotes, so it may contain maximum number of asymptotes n. If the degree of the curve is n, then number of asymptotes cannot exceed n. It may be n or less than or equal to n. So general method of finding asymptotes is, step first, you see the nth degree terms in the expression of curve. Select them and put x is equal to 1 and y is equal to m in the nth degree curve. Nth degree of the given expression, you will get some expression of nth degree in m, denoted by phi and m as, so phi n m. Phi n m. It is a nth degree equation in m. Put it equal to 0. So it will be an algebraic equation of nth degree. It may contain n or less than n real roots. Solve it for m. Suppose that you get n different values of m, say m1, m2, m3, mn. The asymptote will be of the form y is equal to mx plus c. So values of m you get. Now we have to find the values of c for different values of m. Note that if all the values of m are real and different, note this thing, all the values of m are real and distinct. For that values of m, c can be find out by the formula minus phi n minus 1m upon phi n m dash. This c is equal to minus phi n minus 1m upon phi n m dash. Phi n minus 1m can be obtained by putting x is equal to 1, y is equal to m in the n minus 1th degree terms of the given curve. And phi n m dash is nothing but the derivative of phi n m. In this expression, put the values of m successively. First put m is equal to m1, then you will get c1. Then put m is equal to m2, then you will get c2. Put m is equal to m3, then you will get c3, and continuously putting these n different values of m, you will get n values of c, say c1, c2, c3, cn. Then put in the equation y is equal to mx plus c. Here y is equal to mx plus c. Put m is equal to m1, c is equal to c1. Then first asymptote is y is equal to m1x plus c1. Similarly, second asymptote is y is equal to m2x plus c2. Third asymptote is y is equal to m3x plus c3 ... Nth asymptote is y is equal to mnx plus cn. So in this general method, you got the equation of n asymptotes in the case when all the values of m are real and different. Now in the case if all the values of m are not different, suppose if you have the values of m are m1, m2, mn. If m1 and m2, two values of m are equal, then you will get two parallel asymptotes. When two values of m are equal. In this case, c can be found by the formula I am telling you, that which is c square upon factorial 2 phi n m double dash plus c phi n m dash plus phi n minus 1 m dash plus phi n minus 2 m is equal to 0. That is c is equal to 1 by 2 c square phi n m double dash plus c phi n minus 1 dash m plus phi n minus 2 m is equal to 0. See this formula here. This c is equal to this. And in this formula, put the repeated value of m. Means if m1 is equal to m2 is equal to m, then put that value of m, you will get two different values of c that are called c1 and c2. Then you will get two parallel asymptotes y is equal to mx plus c1 and y is equal to mx plus c2, where m is the repeated value of m. So if the two values of m are repeated same, then you will get two parallel asymptotes. Similarly, if the three values of m are equal, means if m1 is equal to m2 is equal to m3, these three values are same, then in this case you will get three parallel asymptotes. The value of m for all three asymptotes will be same because m1 is equal to m2 is equal to m3, and it is the gradient of the straight line of a straight line. So if the gradient is same, the lines are parallel. And for finding the different values of c, the similar formula that is given by c is equal to 1 upon factorial 3 c cube phi n m triple dash plus c square upon factorial 2 phi n minus 1 m double dash plus c phi n minus 2 m dash plus phi n minus 3 m is equal to 0. In this formula, put the repeated value of m, you will get a cubic equation in 3. Cubic equation in 3 means it is a third degree equation in 3. So solving this, you will get three different values of c, say c1, c2, c3, and putting these values of m and c, you will get three parallel asymptotes. They are y is equal to mx plus c1, y is equal to mx plus c2, and y is equal to mx plus c3. So you will get three parallel asymptotes of the curve. Clearly understand that phi n m is obtained by putting x is equal to 1, y is equal to m in the nth degree term. Phi n minus 1 m is obtained by putting x is equal to 1, y is equal to m in the n minus 1th degree terms of the curve. And phi n minus 2m is obtained by putting x is equal to 1 and y is equal to m in the n minus 2th degree term, and so there is no doubt. You can clearly understand to find the asymptotes of any curve by this shortcut and general method. Note that the asymptotes parallel to the y-axis cannot be obtained by this general method. Why? Because if the asymptotes are parallel to the y-axis, then that asymptote will make angle 90 degree with the x-axis. So theta will be 90. So m is equal to tan theta is equal to tan 90 is equal to infinity. They cannot be calculated. So note, due to this reason, the asymptotes parallel to the y-axis cannot be obtained by this general method. So now I will tell you the method of finding the asymptotes parallel to the y-axis. In this case, see the equation of the curve. Collect the highest degree coefficients or highest degree of y. Collect their coefficients in the form a y raised to the power n, where y raised to the power n is the highest degree coefficient of y. And if the coefficient of y raised to the power n, means coefficient of highest power of y, if it is constant, then there is no asymptote in the curve exist parallel to the y-axis. If this coefficient is not constant, then asymptotes parallel to the y-axis is obtained by putting this coefficient a is equal to 0. For example, if the curve is the cissoid y square 2a minus x is equal to x cube. Suppose the curve is given by y square 2a minus x is equal to x cube. And you have to find out its asymptote parallel to the y-axis. See the curve. The highest power of the y in this curve is y square. And its coefficient is 2a minus x, which is not constant. So asymptotes parallel to the y-axis is obtained by putting this coefficient is equal to 0. Putting this coefficient equal to 0, we get 2a minus x is equal to 0. So x is equal to x is equal to 2a. Clearly x is equal to 2a is the asymptote parallel to the y-axis in the curve y square 2a minus x is equal to x cube. Similarly, first I have told you a simple curve hyperbola. xy is equal to c square. Here you are seeing that the curve is xy is equal to c square. The highest power coefficient of y is power 1. So and the coefficient of y is x, which is not constant. So the asymptote parallel to the y-axis is equal to x is equal to 0, means y-axis itself. Now a shortcut method for finding the asymptotes parallel to the x-axis. Thus, in the similar way, if you have directly wants to find out the asymptotes of a given curve parallel to the x-axis, then see the equation of the curve. See the highest power of x. If it exists in 2 or 3 places, then collect it and see the coefficient of highest power of x. If it is constant, then there is no asymptote parallel to the x-axis. If it is not constant, then simply you put this coefficient equal to 0, you can get the asymptotes parallel to the x-axis. In the similar curve hyperbola, you are seeing that the equation of the hyperbola here is given xy is equal to c square. So the highest power occurring in this curve of x is 1 and its coefficient is y, which is not constant. So asymptote parallel to the x-axis is obtaining by putting its coefficient 0, means y is equal to 0 minus x-axis. So x-axis is itself a asymptote of the curve hyperbola xy is equal to c square. So now if you have given any curve, you can find all of its asymptotes by this shortcut method and applying the method asymptotes parallel to the coordinate axis. And some shortcut methods are also used here. One of them is we explain you if the equation of the curve can be put in the form of phi n plus phi n minus 2 is equal to 0. Means if the equation of the curve can be put in the form of phi n plus phi n minus 2 is equal to 0, where phi n represents the nth degree terms in the curve and phi n minus 2 represents the n minus 2th degree curve of this curve. If the curve can be put in this form, first condition, and the second condition is that if phi n can be factorized into n linear factors, then the asymptotes of such type of curve can be directly given by putting the linear factors equal to 0 of phi n m. It can be explained here in the curve hyperbola xy is equal to c square. The degree of the term xy is 2, so n is equal to 2, and c square is of degree 0. So this curve simply you can see that it can be written as phi 2 plus phi 0 is equal to 0 or c square. This curve can be put in the form of phi n plus phi n minus 2 is equal to 0. So by this shortcut method, and second condition is that x, y has linear factors x and y. So asymptotes of this curve are given by putting simply the linear factors of phi n is equal to 0. So linear factors, first asymptote is x is equal to 0 and the second asymptote is y is equal to 0. So by direct this method, phi n plus phi n minus 2 is equal to 0, we tell you that the asymptotes of xy is equal to c square is given by x is equal to 0 and y is equal to 0. These are some simple examples I have explained you here, and some of the examples I will also explain. One simple example here, see that. So that the asymptotes of the cubic, very important question, very simple question. The curve is given by x cube minus 2y cube plus x by 2x minus y plus y bracket x minus y plus 1 is equal to 0. Simply collect, it is equation of third degree. You will collect the third degree terms, put x is equal to 1, y is equal to n, find phi 3n and equating to it equal to 0, you get 3 roots of n. They comes out to be 1, minus 1 and minus 1 by 2. these three values are real and different. So you can find the C by the formula C is equal to minus phi 2m but a phi 3m dash. Putting in this formula, put the values of m successively 1, minus 1 and minus 1 by 2. You will get the different value of C. C is equal to 0, C is equal to minus 1 and C is equal to 1 by 2 respectively. So you get asymptotes are y is equal to x, y plus x plus 1 is equal to 0 and x plus 2y minus 1 is equal to 0. Three different asymptotes you have find out. These are the some important problems I have discussed you. Now another simple method I will tell you. Note this. If the curve can be expressed in the form y is equal to mx plus c plus a upon x plus b upon x square plus dot dot. Note, if the curve can be expressed in this form, then its asymptotes are given by y is equal to mx plus c. Some important example of this type of form is given by, you have to suppose you have to find out the asymptotes of the hyperbola x square upon a square minus y square upon b square is equal to 1. The curve is given by x square upon a square minus y square upon b square is equal to 1. So y square upon b square is equal to x square upon a square minus 1. So y is equal to plus minus under root b upon x bracket 1 minus a square upon x square raised to the power 1 by 2. And extending this expression by one binomial theorem, we get that this curve is expressed in this form y is equal to mx plus c plus a upon x plus b upon x square plus dot dot dot. So by this method, its asymptotes are directly y is equal to mx plus c. Using this, when x is tending to infinity, using this we get y is equal to plus minus b upon a x, which are the required asymptotes of this curve. Thank you. Study well and prepare for